Hello and welcome to Algebra 2 video. This is a video over section 8, which is called function inverses. Okay, and our objectives today is to find the inverse of a function and then to use composition to verify that functions are in fact inverses. Okay, so what I want to do is kind of just talk about what a function inverse is. In the most simplest terms, it's when you switch x and y values. Okay, and we'll kind of talk about what that all means here. But what we have here is we have a function in orange. Okay, the function is in orange, and so you've got the point -4, 7, 0, 5. Okay, and then 6, 2. So you've got some of these points on the graph, 0, 5, and 6, 2. Now, on the inverse function, the x and y values have been switched. So instead, you've got the point -7, -4. You've got the point 5, 0 on that graph, and then you got the point 2, 6. Okay? And so what you notice about these, or what I notice about them especially, is that they are reflected over this line, y equals x. This is a line of reflection. Okay? And then the same thing over here. All right, and let me just go back in and say, okay, this was the point 0, 5, okay, and then the point on the inverse was the point 5, 0. Okay, same thing over here. The point on this function was 6, 2. So then the point on the inverse is the point 2, 6. Okay. And so we get a function here, okay, f of x is equal to -1/2 x plus 5, and that's the orange line here. And then the inverse, denoted by the f to the -1 power, which is how you write your inverse, is the function -2x plus 10. So I will show you guys later on how to get these, all right, by a couple quick steps, okay. But the idea of an inverse function, okay, an inverse function maps the range or output of a given function back to its domain or input, okay? So then, if these two things are inverses, okay, if g is the inverse of f, then, you plug in an x value and you get a y value as a result, all right? If you were to take the inverse, you would plug in the y value, and as a result, you'd get the x value. Okay, so it just goes backwards, all right? And so, okay, so here's what we have. Let's take a look at this first question. We have this function here, okay, and this is our x values and our y values. And it says which ordered pair is on the inverse, okay? Inverse means we switch our x and y's. So the point here that I'm trying to make is that we may have this point of -4, -2 on our function. This is on the function. Okay, we don't have the point -2, -2, but what I do have is this -1, -2. Okay, notice how this is a y value and this is an x value, and what we've done is we've switched them to get the point -1, -2. Okay, this is the value. This is the point that we want. Okay, this is on the inverse. All right, and the only reason why I got that is because I looked here and I saw that I had the point, 2, -2, -1. Okay, this is on the function. Okay, and so if I want to know what point is on the inverse, then I just switch those values, and that's on the inverse. Okay, then it wants to know the range of the inverse of f of x. So if I want the range, that means y value. Okay, the y values of the inverse. Okay, remember inverse means you switch your x and y values. So the y values of the inverse. Okay, so let me write this. The y values of the inverse are the x values of a function. Okay, so if I wanted to find the range of the inverse, I want to look at the x values on my function. So my range, my range is equal to the set of numbers -4, -2, 0, 2, and then 4. And that's all I'm looking for. Okay? All right, so then, this model over here just shows kind of what a function does and then what its inverse does. Okay, and if you were to sit here and plug in 6 into your function, then you'd get 3. But then if you took your inverse and you plugged in 3, then you would get 6. So what I want to do is I'm going to come over here and I'm going to talk about some notation. Okay, so some notation. And on this notation, let's say that I have a function f of x is equal to, say, 1/2 x. Okay? Then if I were to plug in, say, f of 6, okay, plug in 6 for x, then that's going to give me 1/2 times 6, which gives me a value of 3. So f of 6 is equal to 3. Okay, now therefore I have on the function, I have I have this point 6, 3. Okay, now the inverse, and I'm just going to give you guys the inverse. The inverse of this function, and I'm going to denote that as f to the -1 of x is equal to 2x. Okay, and so. And what I would do, remember for the inverse, we switch the x and the y values. So if I'm going to find the other point, I'm going to do f inverse of 3, okay, and plug that in, and I get 2 times 3, and f inverse of 3 is going to give me positive 6. So therefore, I have the point 3, 6, okay, and all I've showed is that the x and y values are switched. Okay, but we'll go over how to actually find these functions here in a bit. Okay, all right, so we have this here, all right, and so if I have a function, okay, f of x is equal to 1/2 x, and f inverse of x is equal to 2x to solve the problems. So what I want to do is I want to find the f of 2, okay, so let me just plug that value into my function. So that's going to give me 1/2 times 2, and half of 2 is just going to give me a value of 1, okay. Now, what I know then is that I have the point on the graph 2, 1. Now on my inverse, it's having me plug in 1, okay, which is your x value. Remember, you switch your x and y values. So we're going to get 2 out of this, okay? That same point on my inverse is the point 1, 2. But let's just verify. Let's plug it into our inverse function. And so then we get this. We get f inverse of 1 is equal to 2 times 1, which is equal to 2, okay? Which then gives me that point, okay? But now we have this. We have this composite function, okay? And this composite function means I'm taking the value f of 2 and then plugging that back into my inverse to see what we get. So f of 2, all right, and remember f of 2 is equal to 1, okay? So really this is then, if it wants me to do, f inverse of f of 2, then I'm taking f of 2, that y value, which is 1, and then I'm plugging it back into my inverse. And so then, if I take 1 and plug it into my inverse function, then I'm going to get f inverse of 1, which we know to give us 2. So here's the, the kind of the thing that I'm noticing here. And let's go ahead and do this, okay? So if I want to do f inverse of -2, all right, that's up here. That's going to give me 2 times -2, which is going to give me -4, okay? So I know this, f inverse of negative 2 is going to give me negative 4. All right, so therefore that translates to the point negative 2, negative 4 on the graph. Okay, now for my function, it's going to be switched. Okay, I'm going to get the point negative 4, negative 2. All right, and if I plug in negative 4, then that's just going to give me 1/2 times negative 4, which gives me negative 2. Okay, and that gives me that point here. So then consequently, what we notice, if I take f inverse of negative 2, okay, f inverse of negative 2, that's going to give me negative 4. So really this is having me just find f of negative 4, which brings me back to my input that I had, okay? So there's an interesting thing that happens here. When I look at both of these examples, where I take, f inverse of a function evaluated at some value, okay, I get that resulting value, okay? That input just gets inputted and then outputted again, and I get that same value. So notice that these two values are the same, okay? Notice how in this one, these two values were the same. So it brings us to this conclusion, okay? If you were to take the composite function, take f inverse of f of x, we know that that's going to be the same thing as f of f inverse of x. And as a result, when you do that, look at what your input is on both of those, and the value that you get is x. Now remember, the line y equals x was the line of reflection on the graph. Of reflection on the graph. Okay? And that's the whole idea of an inverse, is that when you have an inverse that's reflected over the line, y equals x. Okay? That's what an inverse does. So when you take each of these functions, and you take a function and its inverse, and you do the composite function where you plug in the function into the inverse, you will always get the value of x, and that's how you can tell if you have an inverse. Okay? Okay, on this next page, it's asking us to select each pair of functions that are inverses of each other. So I have these two functions, f and g, okay, and these are as a set of relations or points. I have two functions, f and g, that are just regular functions, and then I have two functions that are in table form. So what I want to do is come take a look at this and see whether these are inverses. And what I notice is that, I have this point negative 5, negative 9. G has that corresponding point negative 9, negative 5. And so what you have to see here is that these are opposite points. The x and y values have been switched. And that occurs at this point, going to this point, these 2 points, these 2 points, and these 2 points. So these are inverses. So these are inverses. Okay? And then here, okay, you have f of x is equal to x plus 7 and g of x is equal to x minus 7. Okay? The way to figure out, given two functions, is to do f of g of x. Okay? Where you would need to do the composite function. So what I'm going to do is I'm going to take x minus 7, and I'm going to plug that into the x of my other equation. So then I get this. Then I get the quantity x minus 7 and then plus 7. Okay? So therefore, what I get x minus 7 and then plus 7. These cancel out and add to 0. All right? So therefore, I just get the value of x. And remember from the last page that if you do a composite function on two different functions and they're inverses, you will always get x. So I know that this is an inverse. Okay, these are inverses. All right. Now on the next one, okay, I'm just looking at my points. This is an x value and a y value. I should find, if these are inverses of each other, then I should find the reverse on the other one. And so I see the point 2, 3, but I don't see the point 3, 2. I see the point 3, 8, but that one doesn't work. Okay. On my function here, I have the point 3, 8, but I don't see the point 8, 3. Okay. Some of these I just shared the same points, but they should be opposites. Okay, so this is not inverses. No, not inverses. okay? Okay, the next thing I want to do is I want to show you how to, this is the steps on calculating inverses algebraically. Okay, so you have these series of steps, and the steps are the same. Okay, it's just step 1, replace f of x with y. Okay, step 2 is switch x and y. Step 3, then you solve for y, and then step 4, you write that in standard inverse notation. So I'm going to go through this, all right? So step 1, okay, before I do step 1, let me rewrite that function, and it's negative 4x minus 8, so f of x is equal to negative 4x minus 8, okay? So the first step I want to do is replace f of x with y, okay? So step 1, okay, to go from this step to the next step, we want to go y equals negative 4x minus 8. So to go from here to here, okay, this is step 1, all right? Then the next step is we want to switch x and y. So the next step, I'm going to rewrite this as x is equal to negative 4y minus 8. All right? Again, going from this step to here is step 2. Okay? Then we want to solve the equation for y. All right? So let me do that real quick. Let me kind of make a page break here. I'm going to rewrite that same function, or equation x minus 4y is minus 8. X equals negative 4y minus 8. Okay, I'm going to solve for y, so I'm going to add 8 to both sides. All right, so then I get x plus 8 is equal to negative 4y. All right, I'm going to do this up here. Okay, I'm going to rewrite this as x plus 8 is equal to negative 4y. Okay, then I'm going to divide by negative 4, divide by negative 4, and divide by negative 4. Okay, as a result, this is what I get. I get y equals negative 1/4 x, okay, you can write that as negative x over 4, doesn't matter, and then minus 2, okay? This all was step 3, okay, solving this for y. And then I have to write it in standard inverse notation, which means I'm going to write it as f inverse of x is equal to negative 1/4 x minus 2. And that's it. That's what I'm looking for, okay? All right, so then it says select the equation as the inverse of the given function. So here's my given function, and let's go ahead and do the same steps that we had. So I'm going to rewrite this as f of x equals, what was that, x minus 3 over 5? X minus 3 over 5. So the first thing I'm going to do is I'm going to replace f of x with y. So I'm going to write this as y equals x minus 3 over 5, okay? Then I switch my x and y value. So I write x is equal to y minus 3 all over 5. Okay, and then I'm going to solve this for y. All right, let me rewrite this. X is equal to y minus 3 all over 5. If I multiply this by 5 and 5 on both sides, okay, I end up getting 5x is equal to y minus 3. Okay, then I'm going to add 3 to both sides. So as a result, I'm going to get that y is equal to 5x plus 3. Okay? Now this is the inverse, but I have to write it as the inverse, and I have to show f to the negative 1 of x is equal to 5x plus 3. All right, and that's it. Okay? So my answer, oh look, it's right here. Isn't that fun? We're having a good time. Okay. All right, on this one, all right, so on these, what we want to do is we want to graph the inverses and determine if the inverses are functions. So we're going to graph the inverses and determine if we get a function or not. Okay, so as a result, when you do this, okay, and I'm just going to kind of zoom in here, I am going to draw the line y equals x, okay, and the reason why is because this is my line of reflection, okay, this is my reflection. So I'm just going to come in here and kind of, crap. Okay, draw that line, and I'm going to identify a couple of points of interest, and that point right here that I see is the point, what looks to be -3. Okay, that's the point 0, -3, according to my graph. And so I'm going to come over here and, no, it looks like -2. Sorry, -2. Okay, disregard this function. Just look at the graph. And so what we see here is if I were to draw its corresponding point, okay, -2, 0, I would get that. Now notice that the slope here is up 1, 2, 3 over 1. Okay, so it's really a slope of 3. And so if I go up, and so up 1 and then over 1, 2, 3, and plot another point here, then that's what we get. All right, and we get these two lines, okay, and they're reflected over the line y equals x. Now the thing that I want you guys to understand and to pay attention to is the fact that, not only is this a function, okay, this is a function, but the inverse is a function as well, okay? So let's take a look at something whose graph wouldn't be a function. And I'm going to graph the same thing. I'm going to graph the line y equals x and kind of just put this diagonal in here. And then what I'm going to do is kind of, map a couple of other points over, and I'm going to have this same point, these two same points. But then I'm going to have the point 2, 4 on the graph. Okay, so that means on my inverse I'm going to have the point 4, 2. Okay, and so I have something that looks like this. Okay, and then what I get, if I do the same thing, I have this point over here, -1, 1, and let me do that in red, -1, 1, and then -2, 4. So -1, 1 is going to be the point 1, -1. Okay, on the inverse, and then the point -2, 4 is going to be the point 4, -2. All right, so it's going to go this way. So here's my inverse. Okay, but what I don't see is as I notice that this isn't a function. Okay, now I can tell. So the conclusion here, the conclusion that we draw, is that in order for an inverse to be a function, then the original function must pass what's called the horizontal line test. Okay. Now, what I mean by that, and let's just kind of talk about that, is let me draw a line here real quick. Okay, and I'm going to take this line, and what I notice is that if I take this line on my original function, in this case it was my orange function, it passes the horizontal line test. And if it passes the horizontal line test, then I know that my inverse is a function. But right over here, what I notice is that this does not pass the horizontal line test, okay? It intersects twice, okay? Therefore, my inverse is not a function, okay? That's all we're looking at. Okay, one of the most famous inverse problems is the formula for calculating degrees and converting them from Fahrenheit into Celsius, or vice versa from Celsius into Fahrenheit. So what we have is we have this formula, F of C, okay, and that's equal to 9/5 C plus 32. And what this does is it calculates the temperature in degrees Fahrenheit given a temperature in degrees Celsius. So you can find an equation for the temperature in degrees Celsius for a given temperature in degrees Fahrenheit by finding the function's inverse, okay? And so what we have, okay, is this. The inverse of this function, all right, and let's do this. Before we fill in these things, let's take f of c, okay, and let's just write it like this. Let's just write f is equal to 9/5 c plus 32, okay? And what I want to do is I'm going to go ahead and just solve this for c, okay? And what I'm going to do is I'm going to subtract 32, and I'm going to get f minus 32 is equal to 9/5 c. And to get rid of this, to multiply it over, I want to multiply it by 5/9, multiply this whole thing by 5/9. And so then I get that c is equal to 5/9 times my Fahrenheit, okay? And then minus, if I take 5 times 32, that's going to actually give me 160, okay? And then I'm going to divide that by 9. So what I have here is I have this function here that shows me the degrees Celsius given a degrees Fahrenheit. So we can go the opposite way. So what I would write is I need to say that I have a coefficient of 5/9 here, 5/9 f, and then minus 160 over 9, okay? And what we know is that, you know, f is a function, okay? F is 1 to 1, okay? And so when you have this function here, all right, you know, this function is a linear function, meaning it is a function, okay? Therefore, c also has to be a function, okay? And since they're both linear, that means that they are also 1 to 1, okay? That's all I got for this video. Hope you enjoyed it, and we'll see you soon. Thanks. Bye.